Okay, everybody. So in 3.1, we started talking about our key features, which were our standards right here. We went over our maximums, our minimums, where the vertex was, if our function was increasing, decreasing, positive, negative, our domain and range, etc. Now, in this next section, we're going to move on to 3.2, and then we're also going to throw in 3.4. So at the moment, we are skipping over 3.3. We will circle back around, but we're going to stick together the 3.2 and 3.4, which is our f.bf function right here, where you can graph quadratic functions using transformations, okay? And then along with that, near the end of this lesson, we're also going to go into whether or not our function is even or odd. Now, before we do this lesson, our 3.2 and 3.4, which is graphing quadratic functions in vertex form, you should have already completed your online Desmos activity where you are discovering transformations on a quadratic function. If you've already done that activity, this lesson will make a whole lot more sense on why things are doing what they're doing. If you have not done that activity, please pause this video and go do that activity. Otherwise, I'm going to be throwing things at you and you're going to be going, really? It'll make more sense if you do that. So first of all, we've already gone over a quadratic function, and up here at the top we've talked about what a quadratic function is in standard form. So that standard form, if you remember, was f of x equals ax squared plus bx plus c. But there's another form of a quadratic function. It's called vertex form, which is right down here. Now, the nice thing about vertex form is you have these letters A, H, and K, which all move your function kind of around the graph. And when it's written in this form, it's really easy to graph a quadratic function. So the first thing I'm going to address is I'm going to address this A value. And this A value is either a vertical, stretch, or shrink. Okay, now vertical, stretch, or shrink, if you did your activity, made your graph either appear skinnier or wider. So a vertical stretch is going to make your parabola do something like this. This is your stretch. Versus a vertical shrink kind of makes your parabola do something like this. This is when your A value is greater than 1. This is when your A value is between 0 and 1. So that's when you're going to get a fraction or a decimal 1/2, 1/4. It's going to make your parabola wider versus when your A value is greater than 1. So 2, 3, 4, 5, your parabola is going to get skinnier. And again, the skinnier is called a stretch and the wider is called a shrink. Now, your H value in here is for horizontal, and your H value is going to move your parabola either left or right. And then the key to remember about your H value, because of this negative in here, is this is always an opposite movement. So if there's like a -2, it really moves the graph +2. If there's a +5, it really moves the graph -5. So it's going to take your vertex and move it left to right. Now, your squared, a lot of people ask me, well, what does the squared do? The squared doesn't do anything. That's just telling you that the graph is a parabola. Okay, so remember we went over that the shape of a quadratic graph is called a parabola. The squared is just telling you that this is a parabola and it makes a U. If I were to put a 3 there, it would be a different graph. If I would put a 4 there, it would be a different graph. If I'd put something else there, it would be a different graph. So the 2, just make sure it's there, but really we don't have to worry about it that much. And then we have our K value. This is your vertical shift, and this is going to move your graph up or down. And then this one is not opposite. Okay, so if you have a +5, the graph actually goes up 5. If you have a -2, the graph actually goes down 2. It's not a negative movement in any way. It just does exactly what you think it's going to do. Let's try a couple of these. Number 1, graph g of x and then compare it to the graph of f of x equals x squared. So if you take a look at the graph, there's already a blue graph on there. That's your parent function. That is what the normal quadratic function looks like before I change anything. And then we have to graph the new one and see how it changed. Now, this is how we're going to do this. If you take a look at g of x equals 2x squared versus just x squared, the difference here is in that 2. So that 2 is in the front. It's being multiplied. That's an a value. So that's either going to make it skinnier or make it wider. Now, from your vertex, your typical graph goes over 1, up 1, and it hits right there, and it goes over 1, up 1, and it hits right there because the parabola is symmetric. What this 2 is going to tell you is you're still going to go over 1. You always, wherever your vertex is, go over 1. That doesn't change. What's going to change then is instead of going up 1, you're going to go up 2. So your only transformation here is you're changing the stretch. So you're going to go over 1, up 1, 2, and you're going to put a dot, and you're going to go over 1, and you're going to go up 2, and you're going to put another dot. Nothing else happened here. So then you're going to try your best to make a parabola. Remember, it is curvy. I better not see any V's. Curvy as best as you can. And then you compare. And the comparison here is it was a vertical stretch by factor of 2. And your graph just got skinnier. That's what the 2 did. It made it skinnier. Let's try again. G of x equals negative 1/3 x squared. Kind of the same thing. Parent graph starts at the vertex, goes over 1, up 1, over 1, up 1. This guy, still gonna go over 1. But now, we have a negative 1/3. So guess what? He's not going up at all. He's going down. And he's going down 1/3. Don't get creative. It's just whatever is sitting there. So over 1, down 1/3 is going to put us right there. Over 1, down 1/3 is going to put us right there. Now, the other thing you should have discovered when you did your activity was that this negative also considered a reflection over the x-axis. So instead of your parabola pointing up, your parabola is now going to point down. The other thing is because your a value is less than 1, it's going to make the parabola wider. So you're going to come out of your vertex, you're going to go wider. Out of your vertex, you're going to go wider. And again, we're not being completely exact here. If you look at my parabola, it's even lopsided. I probably could have done a better job here, but I want to see your parabola opens upside down, and I want to see it being wider than the original parabola. That is what the negative 1/3 is going to do. Now, one other thing before we move on. This is not a linear graph. So you know how I just went over 1, down 1/3? And then I went over 1, down 1/3. You can't keep doing that. It's not like a line where you go up 2, over 1, up 2, over 1, up 2, over 1. This is not a line. So you can only do that once. You can only come over here and go down 1/3 once. If you come over again and go down 1/3 again, it's not going to work. Notice that my graph is down too far. It only works for the the vertex, and then the 2 points that come out of it. It doesn't keep working like a line. So I do not want to see over 1, down 1/3, over 1, down 1/3, over 1, down 1/3. No, 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 no. Just do it once and then make a U. Next example, letter D. G of x equals x squared plus 3. Now, this time I have a plus 3, but notice that the 3 is not right here in front of the x. So this is not a vertical stretch or shrink, it's something else. The other thing I want you to start looking at is parentheses versus no parentheses. If I go back up here to my vertex form, parentheses is going to move left or right. No parentheses is going to move up or down. So when I'm looking at this guy, that plus 3, that's a vertical shift. And because it's a plus 3, it's going to move it up 3. Now, From my vertex, once I figure out my vertex, there's no a value, meaning the a value is 1. So I'm still just going to stick with over 1, up 1. Now, what this means to do, take your original vertex. It's at 0, 0. You're going to move it up 3. 1, 2, 3. Bam. That's where your new vertex is. That was the transformation. Then, because I didn't change the vertical stretch, I didn't change the vertical shrink, it's still essentially the same size. So you're still just going to go over 1, up 1, over 1, up 1. Just like you did down here. Over 1, up 1, over 1, up 1. Because we didn't change the a value. And then you draw your parabola. Boop. Boop. And you're done. So the transformation on this one was up 3. You just moved it up 3. Next one, x squared minus 2. Same thing. I don't have an a value, but I do have a minus 2. The minus 2 is on the back, and that minus 2 is just going to tell you to move your parabola down 2. So I go from 0, 0, down 1, 2. There's my new vertex. Then my a value is going to say from my vertex, go over 1, up 1. Over 1, up 1, over 1, up 1, and then draw your parabola. It better not look like a V. And again, you don't go over 1, up 1, over 1, up 1. Do you notice that if I did that, it's not there. It's up further. So it doesn't work like a line. You don't go over 1, up 1, over 1, up 1. That's a no-no. You just do it once, draw your parabola. Last example for this, letter C, g of x equals 4x squared plus 1. So this time, up 1. So I take my vertex, I move it up 1. Now I'm looking and I'm going, wait a minute, there's a 4. The 4 is my a value, so the a value always goes over 1. Always. That doesn't change. Don't second guess that. But the 4, now it's a positive 4. You know, positive means up, negative means down. Up 4. Which means the 4 is pretty big. That's bigger than 1. So this thing is going to get really skinny. So over 1, up 1, 2, 3, 4. Over 1, up 1, 2, 3, 4. And you do it on both sides because the parabola is symmetric. And then you're going to make your best, not a V. Don't draw a V. It's a U. So I'm going to try my best. Oops. And then do you notice that not only is he moved up 1, but he should be a whole lot skinnier than the original blue parabola, the parent function.